Good afternoon, everyone. We're Team 18. My name is Dustin Crooks. My two teammates are Palomo and Ramon Cordero. Today we're going to talk to you about gearboxes and specifically our 4-stage gearbox design. Some initial requirements that need to be met by our system are input horsepower of 1.5. It's going to transmit motion from 660 RPM to 30 RPM and perpendicularly. And both shafts will either spin clockwise or counterclockwise. Our transmission will also withstand moderate shock and achieve an overall factor of safety greater than 1. We're going to test these requirements using ACMA standards. Some applications for our gearbox can range from small household applications like paper shredders to larger applications like waste management and also centrifugal water pumps or air compressors. When doing some research, we found some alternate designs with similar applications to ours using a C-face or worm gear. These were good because they transferred the motion within one stage, but it was very inefficient when transferring power. So notable companies are Hub City, Winsmith, and Boston Gear. I'm going to let Christian tell you some more.
Hi everybody, I'm going to talk to you about the alternative design that we came up with in lieu of a 4-stage gearbox. Our alternative is a 3-stage gearbox, which is more compact. However, with this being more compact, it has a lower factor of safety due to the higher gear ratio needed at the bevel gear. It initially has a 4-to-1 bevel gear into 2 sets of spur gears, which is a 2.75 to 1 and a 2 to 1. So we decided to use our final design in lieu of this one. Has a greater factor safety. For our final design, as I said, is a 4-stage gearbox with an input shaft leading into a bevel gear, which is a 2-to-1 ratio, to another 2-to-1 spur ratio, which is a 14.5 pressure angle. All of them are actually 14.5 pressure angle. And then it goes into a 2.75 to 1 and a 2 to 1 at the end, leading to the output shaft spinning at 60 RPM. And the casing is designed by Ramon. It's actually custom. It's a CDR. I'm going to show you a quick video of our design in action. And if you can see in the video, as it clears away, the gears are actually moving in the right speeds with a 660 at the beginning and a 30 at the end. For our structural design, we decided to use a 1018 steel for the shafts, which will be able to handle the axial and tangential loads on each of the gears, and as well as the the bearings. The bearings we chose from the Timken catalog, which are deep groove ball bearings, which will handle the axial, tangential, and radial loads from the bevel gears from throughout the rest of the gears. Is a pressure fit, and we also decided to use a pressure fit keys for the design for holding the gears into the shafts to keep them in place. I'm gonna let you talk. I'm gonna let Ramon talk to you about the cost analysis.
Alright, the following table displays the total cost for the gearbox system. Basically, it shows the individual cost for all the bevel gears, the spur gears, the ball bearings, the shafts, and the transmission housing. And with its respective catalog number, its manufacturers, which for all the gears it was Boston Gears, for the ball bearings it was Timken's, and for the shaft it was WJB Group. The total cost was $4,046.17. This table basically shows the important process that must be done when maintaining a gearbox system. Basically, it shows the time intervals where the inspections has to be made. An inspection meaning that they have to observe if any dust particles or any debris will interact with the system and make it malfunction. You also have to check for oil levels, for noise level, for vibration levels, and for any damages or oil leakages. And if any of these things are going wrong, then a complete overhaul has to be done of the entire system. And this is basically an animation of an application that could be used for our gearbox system. It shows the motor and a centrifugal pump. It shows how the motor will transmit 1.5 horsepower to our gearbox system, which will be transmitted from the 660 RPM input shaft to the output shaft of 30 RPM. And in conclusion, the things that were met and accomplished was basically we made a gearbox system that met all the requirements, that met all the criteria. It had a good factor of safety of above 1. It also is reliable and has high life. What we learned was the basic aspects of an engineering of how to choose and how to select gearboxes and the gears and the bearings of all the gearbox systems. And also for future considerations, basically we will probably use different type of gears, maybe helical gears and different catalogs that will give lower levels of cost.